Dear students, under the topic applications of derivatives, we have problem 7 here. Problem 6 we have solved in our previous video, which is a similar problem of this type. So kindly follow that problem first and then you can go through this problem. Now the demand function is given as y equal to 100 minus 6x square. The question is to find the average revenue, marginal revenue, and also to prove the relation dr by dx is equal to 1 y multiplied with 1 plus 1 by elasticity of demand. This was given as elasticity of demand, the inverse. Now in this problem it is just given as the reciprocal, that is 1 by elasticity of demand. So both the conditions were same only. So now, first we have to find the revenue in order to find the average revenue and marginal revenue. We know that the revenue function is given by capital R, which is equal to the product of x and y. So x multiplied with y. So from this we obtain R to be equal to x multiplied with what is y given in the question? It is 100 minus 6x square. And so therefore R is equal to 100x minus 6x cube. So this is capital R. The next question is to find the average revenue. We know that the average revenue is equal to R divided by X. That is, if the revenue function is divided by X, we obtain the average revenue, which is equal to 100x minus 6x cube divided by X. Now, in the numerator, X can be taken out, so it becomes 100 minus 6x square divided by X, so that we can cancel these two X, and therefore the average revenue will be equal to 100 minus 6x square. The next question is to find the marginal revenue. So the formula for marginal revenue is the first derivative of the revenue function, that is dr by dx. So what is r? R is equal to 100x minus 6x cube. That is what we have obtained. We have to differentiate this r with respect to x. So 100x, when x differentiated, we get 1. So it will be 100 multiplied with 1 minus, now the differentiation of x cube we have to do, which is 3x square. So that 3 gets multiplied with 6 and it becomes 18x square. So minus 18x square. So this is the marginal revenue. The next is we have to show that the marginal revenue satisfies this relation. Now, in order to show this, first we have to find the elasticity of demand given in the question. So, what is the formula for elasticity of demand? It is equal to y by x multiplied with dx by dy. Now, in order to find the elasticity of demand, we should first know what is dx by dy. For that, we should take the y given in the question and we have to write. So, what is y? So y given in the question is equal to 100 minus 6x square. So from this we shall find dy by dx. That is, we have to differentiate this once with respect to x. 100 is a constant, so it becomes 0. And the differentiation of x square is 2x. So 2 gets multiplied with 6 and it becomes minus 12x. So this is dy by dx. In order to find the elasticity of demand, we need dx by dy. So let us take the reciprocal of this. So from this dx by dy will be equal to minus 1 by 12x. So this is dx by dy. Now let us substitute that over here. So the elasticity of demand will be equal to, and y is, we have y here, so y can be replaced by this. So it becomes 100 minus 6x square divided by x. So y by x is over, multiplied with dx by dy, which we have obtained here. So it is minus 1 by 12x. So we have to multiply these two. So when we multiply, we see that this minus, when we multiply, this term becomes negative and this term becomes positive. So I'm just rewriting it, 6x squared minus 100, because we are multiplying this term with a negative sign, divided by this 12 constant comes as it is. X multiplied with x gives us x square. So this is our elasticity of demand. But actually we need the reciprocal of the elasticity of demand in order to substitute over here. So what will be the reciprocal of elasticity of demand? That is 1 by elasticity of demand. So 1 by elasticity of demand will be the reciprocal of this. So the numerator becomes the denominator and the denominator becomes the numerator. So 12x square comes to the numerator divided by 6x square minus 100. So now after finding this, we shall substitute in the right hand side of this relation. That is 1 by elasticity of demand we will substitute here, and then on simplification we shall show that it is equal to dr by dx. So now here we have taken and written the RHS, which is y multiplied with 1 plus 1 by elasticity of demand. Now we shall substitute this 1 by elasticity of demand over here. We have obtained it to be 12x square minus divided by 6x squared minus 100. So when we substitute, what do we get? We get this to be equal to y multiplied with 1 plus 1 divided by elasticity of demand we have found here, that is 12x square divided by 6x square minus 100. So 6x square minus 100. So if you take the LCM on the right hand side, so we get y multiplied with the LCM will be 6x square minus 100 in the denominator. We have to multiply this with 1. So 6x square minus 100 and then plus this 12x square. Now if you see, this becomes y multiplied by, what is 6x square plus 12x square? It is 18x square and then minus 100 divided by. Now this 6x square minus 100 can be written as, from the question, see here, we know that y is equal to, what is y? Y is equal to 100 minus 6x square. This is from the question. Okay, now here in the denominator we have 6x square minus 100. So this has been multiplied with a negative sign. So minus y will be equal to minus 100, minus into minus plus 6x square. So that is 6x square minus 100. So 6x squared minus 100 is nothing but minus y. So instead of 6x squared minus 100, you can replace it by minus y. Now this y and y gets cancelled. So we have minus 1 here. This minus 1 has to be multiplied with the numerator and we get minus 18x square. Minus into minus will become plus 100. So therefore, the right hand side is equal to 100 minus 18x square. But what is this 100 minus 18x square? We have already found it as dr by dx, that is the marginal revenue we obtained as 100 minus 18x square. So this is equal to dr by dx, which is the left hand side of the given relation. So if you see, this is the left hand side of the given relation, dr by dx, and we have proved that it is equal to the right hand side. Hence we have shown this relation also. So hence we have shown the given relation. So I hope you would have understood this problem. This is a very significant problem in the examination point of view. So kindly follow the next video lecture for 15 mark problems under this topic. Thank you.